Now we're going to get into some special cases. So some linear equations, instead of in these previous examples where we only got one solution, some linear equations can have either no solution or infinitely many solutions. And let's explore now how we know whether it's got one solution, no solution, or infinitely many solutions. So let's solve this like we normally would. Distributive property, so we get 8x minus 20 equals 8x minus 20. Well, at this step, you'll notice the left-hand side and the right-hand side are the exact same. So let's see what happens when we solve this. Let's get our variables to one side. Well, both of our variables cancel out, and we're left with negative 20 equals negative 20. Well, is that true? Yes, it is. This is true. Always going to be true. It's never not. Negative 20 will always equal itself. So since we get an always true statement, this is infinitely many solutions. And what that means is you can plug in any number you want for x, and it will always work. The left-hand side will always equal the right-hand side. You can plug in 0 for x. You could plug in 125 for x. You could plug in negative 3,427 for x. No matter what you plug in for x, it's always going to be true, which means that this linear equation has infinitely many solutions. You can plug in decimals, fractions, huge numbers, small numbers, negative numbers, positive numbers. It doesn't matter. No matter what you plug in for x, it's always going to work. Okay? So if you end with a true statement, if your variables cancel out and you're left with a true statement, that's infinitely many solutions. So let's see the other case. Still doing distributive property. Negative 12 plus 6x equals 6x plus 2. So here we see that the variables are the same, 6x and 6x on both sides. So if I try to get the variables on one side, they're both going to cancel, and they're going to leave me with negative 12 equals 2. The issue is that's not true. That's not true. That's a false statement. Negative 12 will never equal 2. So since that's false, that means that this linear equation has no solution. There's nothing that you can plug in for x that is going to make this equation true. Okay? Let's get into another type of linear equation. Something that looks like this. This looks a little bit different. If I want to solve for x here, we're going to start by cross multiplying. So these are proportions. So if you think of like a simple proportion of 3/4 equals x over 5, you would just cross multiply, get 4x equals 15, and be able to solve it from there. It's the same idea. So if I'm going to cross multiply, I'm going to take 9 times, how did that go away? Sorry. So if we cross multiply here, we're going to get 9 times x plus 1. And if I cross multiply on the other one, I'm going to get 3 times 4x plus 5. Well, these are just like the problems we started with. Now we got variables on both sides. We got a little bit of distributive property. So we have 9x plus 9 equals 12x plus 15. Get our variables on one side, our numbers on the other. And then we solve this one-step equation, and we're going to get x equals negative 2. Okay? Go ahead, pause the video, try out letter B. Should get x equals negative 2 for that one as well.